Yes. Yeah, good evening all. So myself, I'm Vijay. I hold like 17 plus years of experience, which includes 8 plus years of experience in Hadoop and Spark environment. So as part of today's demo, I'll be covering the following things. So before that, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Yes. Can
Yeah, I
anyone?
can see
Sir,
your
it's
screen and
audible.
able to hear it.
So first, okay. What is Apache Spark? Why PySpark? Need for PySpark? Spark Python Scala, right? Spark Python and Scala, and which one means Spark can be implemented mostly by using Scala and Python, which is preferred mostly. And what are the differences? PySpark features. Real life usage. Of PySpark. PySpark job market. Okay, so this is what I'll be covering, right? What is Apache Spark? I define Spark, right? Yes, Apache Spark. Spark is a open source. It's an open source distributed framework in parallel process style with in-memory computation feature in-memory computation features, right? Used for large scale data processing. So I define Spark in finance, open source distributed cluster computing, right? Framework in parallel process style with in-memory, sorry, it's in-memory computation used for large scale data processing. I can say it's a general engine for big data analysis, right? For processing and computations, right? Fine. And if you say why we need to go for this Spark, why PySpark? Why PySpark, right? Yes. It's a why PySpark? PySpark, I can say, is a Python API. Python API, right? To use a Spark. PySpark is a Python API to use Spark. As I said, it's a cluster computing system which is used for big data solution. I can say like PySpark. It's a lightning fast technology, right? Used today for design, especially for fast computation. So PySpark is a very demanding. It's a very demanding tool among the data engineers today to work with bigger data sets, right? So generally, what we do, right? PySpark, right, is used for right running distributed SQL, creating data pipelines, ingesting data into database, mainly right running machine learning algorithms, machine learning, right? So, and also like working with graph or data streams. Okay. Running distributed SQL, and creating data pipelines, right? Ingesting data into database, running machine learning algorithms, working with graph or DS streams. Okay. What is the need for PySpark? So if you see today, like large amount of data is generating both through offline and through online, right? So this data contains hidden patterns, unknown corrections, market trends, customer preferences, and other useful information, right? So which is necessary to extract valuable information from this raw data, right? So we require a efficient tool to perform different types of operations on this huge data. So there are various tools to perform this multiple tasks on this huge data, but those tools are not much appealing. So it's need some scalable and flexible tools to crack this big data and gain benefit from it. So PySpark is such a kind. So I can say a combination of Python and Spark. Combination of Python and Spark will be the very efficient for the world of big data. That's why Apache Spark community came up with a tool called PySpark. That is Python API to use Spark. Python API to use Spark. So like say like PySpark. Okay, fine. Python programming language and Apache Spark execution, right? So Spark is an execution model implementing using Python. Okay, and most of you asking curious, right? So differences between Spark implemented with Python and Spark implemented by using Scala. See, one thing, Spark can be coded with Scala. Spark can be coded with Python. Spark can be coded with Java also, right? It can be also be implemented using Java and also by using our language. So mostly like the drawback of MapReduce in Hadoop, right? Because of huge Java codings. That's why it has been outdated because of this huge coding. So people started migrating to other environments, right? So mostly like the Spark implementations, most of the implementations using Scala and Python. By default, Spark built using Scala, default, right? Spark built by using Scala, and Scala is the native language of Spark. But today, like Python, Spark implementing using Python, right? So today Python also widely used for implementing Spark. Previously, Scala was used more. Now, if you see, Python is used more. So if I talk about Python and Scala, right? Python and Scala, if I see the difference, right? Python is dynamic. Python is dynamic typed. Scala is static typed. Python is, see difference between this Python, Scala. Python is dynamic typed. Scala is static typed. Dynamic type means, yes, dynamic data types we can select. No need to specify what type of data, just what value you are assigning. See, for example, x equal to 10. If you say x equal to 10, no need to give the data type int or float, right? So what value you are assigning to x? Integer value. Then integer variable gets created, right? Y equal to 4.5. What value you are assigning? A float value, that's why type will be float type, a variable. What type of variable created means float variable. Based upon what value you are assigning, so the variable is going to get created accordingly during runtime. That's what we say like dynamic type. And one more, Python. Python has large community as compared Python is open source. Python is open source, right? And has a huge community. Python has a large community. But Scala doesn't, it's not, it doesn't have a small community, right? But Scala also has a got an excellent community, but lesser as compared with Python, it is lesser, right? So Python has got powerful libraries. Python has powerful libraries, especially for ML and graph algorithms, as powerful libraries for ML and graph. Yes, so it's dynamic type, but Scala is static type. It's an open source. Python has a large community, as Scala has a smaller community, as powerful libraries for ML and graph algorithms. Like Python, right? If you see, even for total entire data science implementation goes in Python, where Python is providing many modules like for plottings, visualizations, for data analysis, clusterings, recommendations, right? So Python is the mostly chosen language for implementing this. We have got modules like Matplotlib, NumPy, CP, scikit-learn, like we have got many models for it. And okay, these are advantages of what Scala, but Scala also has got advantage over Python, right? Both are equally used, but mostly today, like Python is mostly preferred. Previously, Scala was used a lot. But what is the advantage of Spark over Python is, what is the advantage of Scala over Python is? Okay, Scala is faster. Scala is faster than Python. Scala is faster than Python, where Scala uses JVM, right? So Scala is faster than Python, where Python is interpretation, right? Statement by statement execution, right? Yes. And what are the main like PySpark features? PySpark features, right? Main features of PySpark. First feature, like what we say, in-memory computation. In-memory computation, right? Yes. In-memory computation means storage and processing happening within the memory level. Both storage and processing happening within the memory level. That's why in-memory computation, right? And second, one more feature, important feature is lazy evaluated. Lazy evolution, right? Lazy evolution means right. Lazy evaluated means until if you perform an action on the data flow, Spark is a data flow language. If you apply any action, then only data flow executes. Otherwise, it won't execute. Just like a normal function, right? If you make a function call, then only it executes. Otherwise, no. 1 second. Lazy evolution, right? Lazy evaluate. Once you perform any action, the data flow is not going to get executed. And powerful fault tolerant model, right? Powerful fault tolerant model, right? Powerful fault tolerant model, right? Yes, the fault tolerance model, right? So whenever where Spark, when the data objects are splitted, divided into multiple partitions, the partitions are distributed across multiple RAMs of multiple worker nodes and are processed parallelly, right? Are processed parallelly. So during this process, if any slave goes down, right, and how it is going to overcome, right? So that's why I will be discussing that Spark has got a powerful fault tolerant model. And immutability. Immutable means this data objects are immutable. Even if you are doing any modification changes, the original data object will be remain same. No changes or modifications will be applied on the original data object, right? Yes. One more important feature like persistence, right? Persistence in Spark. If you means reusing already executed transformation, reusing the already executed transformation, right? Yes. Okay, persistence feature. So these are the main features in memory computation, lazy evolution. If you make an action, then only the data flow executes. Powerful, fault tolerant, immutable, and persistence, right? Yes. Okay. Real life usage of PySpark. Real life usage of PySpark, right? First, in commercial sector, right? In commercial sector, first, in Apache Spark, the PySpark real-time processing, so mostly used in the banks and in financial fields to retrieve the customer's social media profile and analyzing to gain useful insights in making and taking the right decision, right? And extracting the information and even for fraud detections, right? And for customer segmentations, right? So, and also in healthcare and real-time usage of PySpark second in healthcare, right? Yes, and within the healthcare. Yeah. Apache Spark is used to, for example, analyzing the patient's records along with the previous medical reports, medical history, right? And which patient is probably to face the issues or even after being discharged, right? Yes. In entertainment industry, right? Entertainment industry. Yes. Is one of the largest sector which is growing towards online streaming, right? So today we are going to online streaming. So popular online entertainment, right? Like Netflix using Apache Spark for real-time processing for this online movies or for web series. And it processes approximately 450 billion events per day. It's just streamed on server-side applications, right? And even on e-commerce trades or e-commerce, right? E-commerce. The leading e-commerce sites like Flipkart, Amazon, all this they use Apache Spark. So you are using PySpark for its advertising and the sites and even the sites which are used for enhanced customer experience and optimizing the overall performance. And even in the tourism industry also, right? Tourism field. Apache Spark used to provide advice to millions of travelers by comparing these hundreds of tourism sites. Yes. So just I'll come back to this explanation, but before that, once have a look at what is going to be discussed as part of this. So what is Apache Spark, need for Spark, PySpark sessions, context, parallel repartitioning and police, broadcast variables, accumulators, right? Operations on RTD, right? RTD actions, transformations, persistence features, options, right? Memory only, disk only, memory underscore S, PySpark core computations, groupings and aggregations, right? Various inbuilt actions and transformations. Inbuilt actions and what are the inbuilt actions and transformations? SQL data frames, right? We are just going to discuss about data frames and data frame APIs, right? And PySpark creating a data frame, right? And PySpark show struct type, struct field, row class, column class, select, collect with column. So I've got many inbuilt features, right? With column, where, filter, drop duplicates, order by sort, group by union, union all, UDF, flat map for each, sample, fill null, yes, aggregated functions, window functions, data and timestamp functions, JSON functions, read and write JSON file, when expr, lit, split, concat, substring, translate, regular expression, overlay, yes, to date format, months, array content. So we have got many functions in this way. Map value struct. We'll be discussing about all this with some working examples. And PySpark external sources working with XML and Spark and Hive integration, MySQL integration, CSV, JSON transformations, narrow and wide transformations, handling nulls, window functions, writing back to external sources, different types of file formats, local mode, cluster mode, PySpark applications, stages and tasks, drivers and executor, building applications, pipelines, deploying, right? And PySpark streaming and integrating with Kafka, PySpark ML, right? This is all in depth. So we'll be discussing all this, right? Yes. Totally, we'll have like 8 weekends, right? This is what PySpark course content you can see in the chart panel. It is given in just to go through, right? Now coming to this. What are the Spark data objects we call like, or you need to have some knowledge about this RDDs, resilient distributed data sets, resilient distributed data sets. Spark data objects, we call them as RTDs. Right, 1 second. Resilient, right? Resilient distributed data sets. Data sets, right? Resilient distributed data sets. So other in-memory computation system in the market, right? We have got SAP HANA, right? Other in-memory computation system like Spark, we have got SAP HANA, but HANA is in-memory computation system, but it's not distributed. But Spark is distributed and follows in-memory computation and parallel process time. Resilient distributed data sets, RDD, right? RDD. Like Spark data objects, right? Spark data objects. Are called RDDs. RTDs are subdivided. RTDs are subdivided, right? Into partitions. And these partitions, RTDs are subdivided into these partitions are distributed. These partitions are distributed across multiple RAMs of multiple slaves. Across multiple RAMs of multiple slaves, worker nodes, right? So here RTD programming style. RTD programming style is data flow. Is data flow. What is data flow? Data flow is a sequence collection of pipes. Data flow is a sequence collection of pipes. Sequence collection of pipes means RTDs. Data flow is sequence collection of pipes, that is RTDs. A pipe is a data operation. A pipe is a pipe, nothing but RTD. Is a data operation, is a data operation. Such as loading data, transforming data, loading data, transforming data, merging data, filtering data, grouping data, sorting data, etc. One more important Spark. Data flow is executed. Data flow is executed in sequence. Data flow is executed in sequence. RTD by RTD. That is RTD by RTD. One after the other. One after the. And Spark data flow is executed in sequence. That is RTD by RTD. One after the other. With in-memory computation and persistence feature, right? So two RTDs can never execute in parallel, but two RTDs can never execute parallelly, right? But if the RTDs, has 30 partitions, then these 30 partitions can execute parallelly, right? Then these 30 partitions can execute parallelly. Yes, I said Spark is a data flow language, right? It's a data flow language. Just observe. R1, RTD1. R1 output is taken as input by R2. R2 output is taken as input by R3. Yes, R3 output is taken as input by R4. It's a data flow, right? So once this, if we say some kind of action, R4.action, then only this entire data flow will be executed from the start to R4. R3.action means from R1 to R3 it executes, R3 output will be collected. R4.action means R1 to R4 it executes and R4 output will be collected. Okay, so how many RTDs, once this flow execution completed, how many RTDs in the RAM? Yes, try to answer how many RTDs will be in the RAM once the execution is completed. Don't think like all these 4 RTDs will be in the RAM. If all the one RTD is a big data object, right? But if you are just accommodating all the RTDs, but if you've got some 50 RTDs in a particular flow, don't think all the 50 RTDs will be accommodated by the RAM. No, already one RTD is a big, large data object. Whenever the second RTD is ready and the output is collected, the first RTD gets removed from the RAM. And once the RTD output is collected and it's ready, then the previous RTD R2 will be removed from the RAM. R4 is ready, then R3 gets removed from the RAM. Once the total output is collected, Then this R4 also gets removed. Now, which RTD in the RAM? No RTD, right? All they got one by one RTD will be loaded and gets removed once the next one is ready. See this flow, right? Once observe this flow, there is a feature called persistence in Spark, right? Persistence in Spark. R1, R2, R3, R4, R5, R6, R7, R8, R9. See, there is a three flows. This is one flow. Flow one. The second is flow two. And this third is flow three. Three flows. Flow one, right? Flow one. See this R1, R2, R3, R4, R7. Flow two is what? R1, R2, R3, R5, R8. Flow three. R1, R2, R3, R6, R9, right? So if I want to execute the flow one, if I want to execute flow one, right? Yes. I need to perform some action. I need to say R7 dot action. Then from first R1 gets loaded. From R1, R2 gets loaded. When R2 is ready, R3 gets removed. When from R2, R3, when R3 is ready, R2 gets removed. R4, when R4 is ready, R3 gets removed. And R7, when R7 is ready, R4 gets removed. Once the total output is collected, R7 also removed, right? No RTD in the RAM. No RTD in RAM. Flow 2, right? Yes. Flow 2. Flow 2. I'll say like R8 dot action, R8 dot action. R1, R2, R3, R5, R8. So once R2 is ready, R1 gets removed. When R3 is ready, R2 partitions gets removed from the RAM. So whenever the next RTD ready, previous RTD gets removed, right? We cannot accommodate all the RTDs. Once the entire execution finished, once the output is collected, this last RTD also removed. No RTD in the RAM, so you can trigger the next flow. Flow 3. R9 dot action, I need to say, then only the flow executes from its root. Yes. Okay, R9 dot action. R1, R2, R3, right. R6, R9, right? Yes. When R2 is ready, R1 gets removed. When R3 is ready, R2 partitions gets removed. When R3 is ready, yes. When R6 is ready, it gets removed. So in this way, once the total output is collected, everything is removed. But here, what is the drawback you observe here in this flow is, in the every flow, you are executing R1, R2, R3. The same steps, right? R1, R2 has got Okay, fine. Okay, fine, right? Yes. Flow 1, flow 2, flow 3, right? Flow 1, flow 2, and flow 3. So here drawback is, even though first three, all these R1, R2, first three series flows are same, right? But still, every time you are re-executing again R1, R2, R3, R1, R2, R3. So in such case, what you can do is, the flow, the output, which is commonly used by multiple flows, that you can persist it, right? Persist. If you persist it, right? If you persist it, right? R1, R2, R3, yes. If you persist, then it will be available in within the RAM, even though the next OTD is ready. If you persist this RT, means the output, means the arteries whose output is used by many flows. Flow 1 is using, flow 2, flow 3. So that if you persist it, it will be remain in the RAM even though the next OTD is ready. Observe here. This is your flow R1, R2, R3. Whether when the R3 is persisted means R4, R5, R6, R7, R8, R9. This is your flow. So executing flow 1. Executing flow 1 means I need to say R7 dot action. First, it checks R7 in, okay, first it executes the entire flow R1, R2, R3, R4, R7. So once R2 is ready, R1 gets removed. When R3 is ready, R2 gets removed. Yes. R1, R2, R3. When R4 is ready, R3 R3 not removed because it is persisted. When R4 is ready, R3 won't be removed. When R7 is ready, R4 gets removed, right? Once the total output execution finished. So R3 is in the RAM. R3 is in the RAM, right? So R3 remains in the RAM. Whenever you execute the flow 2, right? You know, whenever you say R8 dot action, as R3 is available directly from R3, you can compute, right? No need to execute the first steps. R3, R5, R8, that's it. Some steps have decreased, right? Even for flow 3 also the same thing, right? R9 dot action means no need to execute from the starting. Directly R3 is there to give the output. So R3, R6, R9, the flow has decreased, right? So that is the importance of persistence. What is that? Even though the other RTDs are ready, then this persistent RTD won't be removed. It will be available within the RAM to give output to the many other flows, right? Yes. Right. Once, okay, once the flow is execution is finished, once the flow execution is completed, if it doesn't want R3, once R5 ready, R3 won't be removed. When R8 ready, this gets removed, this gets removed. Here also R3 in the RAM. When R9 is ready, it gets removed. Once the execution is completed, this. In all the cases, R3, 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 R3 is within the RAM. In all the three cases, R3 is within the RAM. Okay. So in all the cases, R3 remains in the RAM, right? Yes. Now, if it doesn't want R3, then you can say forcefully unpersist it. R3 dot unpersist. One way. Otherwise, if server shutdowns, three ways to unpersist, right? R3 dot unpersist, forcefully can unpersist when server is closed, when server shutdowns, when session is closed. So for unpersisting and RTD, if server shutdowns, it gets unpersisted. If session closed, it gets unpersisted. R3 dot unpersist, right? Right? Yes. Persisting in RTD means what is the advantage we see? Already executed transformation output, the R3 output can be reused. R3 output can be reused, right? Okay, fine. So, okay, any queries you have got, right? And this, so this is the course content we'll be discussing, PYSPARK, PYSPARK RTD computation, PYSPARK introduction, persistence options, PYSPARK core computing, and groups and applications, various actions it trans PYSPARK SQL data frame, right? SQL functions, but different PySpark built-in functions we'll be discussing, external sources, deployment modes, like this. Fine. Okay. So we'll have a small break of 15 minutes, right? And we'll continue more on this same, right? RTD computation, right? RTD computations, persistence, right? Persistence of an RTD and RTD computations, actions, different inbuilt actions and transformations, right? So 1 second. Any queries from your side before that? Before we go for break?
Yeah, hi. This is Srinivas.
Yes.
So actually, like over the weekends, how many hours of this class? Like daily 2 hours or 3 hours?
So it's a weekend batch. First thing is a weekend batch, right?
Mm-hmm. Yeah,
Only on
okay.
only on Saturdays and Sundays we'll be having this session. Uh, the timing is so okay. So for, okay, this is what every week it will be like 5:30 to like 7:40 or 7:45 it will be. 5:30 to 7:30 or 7:40 it will be, right? Right. Day every week it will be in this way, right?
Okay. Actually, 5:30, 7:30, it's not feasible for me. Is there any other time, like whether you are going to start in future, like maybe after 15 days or 1 month from now?
What is the time feasibility for you?
It would be okay in the morning time, like morning 8 to afternoon 12 in between.
8 to 12. Oh, no, no. So as of now, this is that batch, right? Previously, like, if any other batches are there, we'll be letting you know, right? So this is the batch.
Okay.
Right.
Actually, I already received the recorded sessions, and yeah, I will go through the recorded sessions. Normally, if I get any questions, right, I will join this call and I will get clarified those
Okay,
questions.
okay, fine. Fine, okay. So yes, everyone you can just in the chart panel, the payment process and procedures is given, right? This and the course content is given. Course content payment process. And after the break, try to follow this other link, right? The link which is given, right? You can see one link. Once again, I'm pasting that link in this, right? 1 second. The one link is given by the online team. Follow that link after the break. Just once again, I pasted now. Okay. So you just copy this link and at 6:10, like 6:10 or 6:15, we'll be starting with it. 10-15 minutes of break and we'll continue
I
more.
also see one more batch starting at 2 p.m. right? Can I join at 2 p.m. Call the 2 p.m. meeting?
Your name, okay.
Srinivas.
There is big data, Hadoop and PySpark, both will be there, right?
Uh-huh.
Big data, what is that? It's for big data, Hadoop and PySpark, both will be covered.
Okay.
I don't know whether if you have registered, you can attend it.
I have registered for PySpark, not for the big data Hadoop.
Yes. So check with the online team, right? They will guide you.
Okay.
Once you got enrolled, you can attend any of my batches, right? But see,
Yeah, I already enrolled for PySpark batch, but not for the big data Hadoop one.
okay. Fine. Okay, that's fine. Fine. You can just have discussion with this online team, right? Yes.
Okay, from when actual batch is starting? From today itself or
From
from
today
next
itself.
week?
From today
Uh-huh.
itself.
Okay.
PySpark will start from today itself.
Okay.
Okay. So just everyone can just have a break of 10 minutes, right? I can join through the other link, right? Yes, the link given in the chart. You can just follow that link right after the back. Fine. Okay.
Are we merging with other batch, sir? Why we are changing the link?
See, there was a demo in the last week, right? There was a
Oh,
demo,
yes.
the demo in the last week. The same demo I've given for you in 1 hour, right?
Okay.
And those two people and these two people, your just introduction to PySpark is given in the last Saturday. And this now you have given the introduction. Now you will be going with the actual part. Fine.
Okay.
Up to, say, for both of them, up to that RTD introduction, what we have discussed from that, it was there. So now we'll be going with the RTD computations, right? Yes. Fine.
Okay.
Fine.